This video describes the design, manufacture, and testing of a roller bearing assembly that mounts on the side panel of the Tormach 8L lathe. This roller bearing assembly encompasses 3 roller bearings that reduce vibration and enables the turning of bars up to 30 inches long on the Tormach 8L lathe. Hello, I'm John Manura. In a previous video I demonstrated this roller bearing assembly I made for my Tormach 8L lathe, the purpose of which is to stabilize the individual bars as I'm machining them by using these 3 roller bearings that clamped around the bar, and definitely reduce vibration. I was able to machine long bars. In that video I was machining these bars which are 26.5 inches long, and I need to machine both ends of the bars. But without a system like this at the end of the bar to stabilize, it just got too much vibration. Any RPM over like 1,000 RPM, it just vibrated all over the place and just impossible to machine them. So that's why I designed this system, and it worked quite well for that project. I machined the ends of like 36 bars in total for that project, and it did work quite nice. But the problem with this system is it's not adjustable. I couldn't adjust these, to get an individual bar to get it, precisely tuned in, and I definitely couldn't do larger diameter bars. But I need to do long bars for a couple of different reasons. First of all, I have a project such as this, which I want to machine the ends of long bars. But I have other projects such as these I made, which I've made a bunch of assemblies, and I made using maybe 100 or 200 of these pieces on the Tormach 8L lathe. And I was using starting bars that were like 12 to 15 inches long. Anything longer than that, it's got too much vibration. But I like to use the longest bar I can, because the longer the bar you use, the less waste in material. Every bar, you lose maybe 2 inches at the end of each bar, just for the amount that has to hold in your chuck. So the longer the bar, the less waste I have in machining these pieces. So I need to have a system that's versatile to use for different size bars for my various projects I'm working on. This system worked quite well, but as I mentioned, it's not adjustable. So I wanted to come up with an idea to make these adjustable. So I went to my Fusion 360 software, started working up some designs. And this is my first design I made. It consists of a 16 square aluminum plate with 3 roller bearings mounted on sliding clamps here. And then these get clamped in position with some thumb screws. And that worked quite nicely for adjusting the bar, getting it right tuned in the exact position I wanted it. And it did work, but the problem with this system is because the bar may not be perfectly straight, there wasn't vibration. Any vibration caused these to move. So what's happening, these were moving down like this. And within a few minutes of operating, the bar was wobbling all over the place because these roller bearings actually moved. So I needed some way to clamp these in position. My first idea was to use some pins that would go in these slots, and that would position the slots in these bar assemblies in 2 positions so they would not move. But then I thought a better idea might to actually put channels in the bar. Use a thicker plate and put some maybe 1/8 inch or 1/4 inch deep channels in the plate, and these bars here would ride in that channel. So I went to my software from my mill and I designed the plate. And I made a prototype out of some plastic. And this is a prototype with 3 channels. These channels reach 1/8 of an inch deep, and my clamps now, with the roller bearings on the end, ride in those channels. So even if that got a lot of downward pressure, it won't move now. So that should work quite nicely. So that's the idea now for the rest of this project, is to design the second version of these roller bearing plates that ride in channels. I'll be making 2 different styles of these plates. In the first design, I'll be using this piece of Delrin. I like using the Delrin because it's easier to machine, it's lighter weight than the aluminum. My concern is if it'll be strong enough for this system, because I do a lot of pressure with the vibration on here, so it may not work, but I think it'll work. But I'll be making a prototype out of this Delrin. This is a 3/8 inch thick piece of Delrin. I also have a 1/2 inch thick piece of Delrin, and this I can put my channels 1/4 inch deep, so I might be trying that also. But then I'll be making a third prototype out of some aluminum. This is a 3/8 inch thick of aluminum 6x6 plate, and I'll be making a prototype out of this. Between the Delrin and the plastic, they're about the same cost, between $1 or $2. So the cost isn't the issue. The issue is strength, and I think the aluminum might be a better option, but I do like using the Delrin if it does work. So the rest of this video, I'll be demonstrating the machining of these plates and then testing of the system to see how it works. Here's another simple fix to help reduce vibration. The diameter of this nut here at the end is what, well, maybe an inch, over an inch in diameter. And the bars I'm cutting are less than an inch in diameter. So I made this little insert to put inside the tailstock piece here. And the OD is a friction fit, real tight fit in there, goes in pretty tight. And the ID I drilled to the exact diameter of the bar I want to put through. So what I do is I put this through here, and then I insert my bar. Hold it pretty tightly. And that just clamps it so it's clamped in my chuck up front. And then back here it's reduced vibration, so it keeps it nice and tight. And it's amazing how much that little change made the lathe run so much quieter. And so I lock my door here so it can operate with the door open. And let me run this and show you what it looks like when I'm running at different RPMs. And this bar is extending, not quite to the case, but extending out about 8-9 inches from the clamp here. So we'll start at 1,000 RPM. See a little bit of vibration here on the bar, but it's running quiet. Let me run that up to 2,000 RPM. And then 2,500 RPM. And if I use this in conjunction with my other stop back here, it should even be better. It should definitely reduce vibration by quite a bit. I plan on making two versions of the roller bearing plate, one out of Delrin Plastic and the second version out of aluminum. I decided to make both of these versions out of 1/2 inch thick plate, each 6 inches square. By using a 1/2 inch thick plate, I'm able to cut grooves 1/4 inch deep for the roller bearing bars. I designed a complete system using the Fusion 360 software. First of all, I designed a main plate with the 3 channels for the 3 adjustable roller bearing bars. I then add the remaining components for the system, which includes the 3 aluminum bars with centered channels to enable the adjustment of the roller bearings, followed by the roller bearings and the brass thumb screws. Next, I use the manufacturing software in Fusion 360 to design the tool patterns and write the G-code. Afterwards, I transferred this G-code to my CNC mill to enable the machining of the main plate and also the 3 aluminum bars. A portion of the video is actually being shown at 10 times the actual cutting speed, again for viewing purposes. After transferring the G-code from the Fusion 360 software to my CNC mill, I begin the machining of the 1/2 inch thick Delrin plate. I use a 1/4 inch square end mill to machine the 1.5 inch diameter center hole and the 3 1/4 inch deep channels for the aluminum bars with roller bearings. I edit this video quite a bit, again for viewing purposes, just to speed it up. The actual machining of this plate took about 35 minutes to machine the plate totally out of Delrin, and to machine it out of aluminum took almost about 45 minutes. This cutting of these slots actually takes quite a bit of time. It's using a technique called adaptive clearing. And adaptive clearing reduces the load on the mill, makes it much easier to machine parts. And I can actually machine the full depth of the cutter without putting excessive load on the tool bit or the mill. I then use a 1/4 inch diameter drill to drill the 4 mounting holes. These holes will later be used to mount this plate to the side plate on a Tormach lathe. Finally, I used a number 7 or a .201 inch diameter drill to drill the 2 mounting holes in each of the 3 slots. These holes will provide 2 positions for attaching the aluminum plate with roller bearings using the brass thumb screws. In a likewise manner, I then machined 1/2 inch thick aluminum plate. I did need to slightly modify the G-code software for machining aluminum plate, since aluminum is more dense and harder to machine than the Delrin Plastic plate. This increased the machining time by about 10 to 15 minutes. After both of these plates were finished machining, I then cleaned up the edges on my belt sander and the surfaces with a fine floppy disc sander. Bars for mounting the roller bearings were machined from an aluminum block 3 inches long by 3/4 inch wide by 1/4 inch thick. A .16 inch diameter hole was drilled into the end of the aluminum block. A number 5 metric tap will later be used to tap this hole for the attachment of the roller bearings. I use a 3/16" square end mill to machine a .280 inch wide by 2 inch long slot in the center of each of the bars. These slots are for 1/4 inch thumb screws and will enable the adjustment of the roller bearings and the aluminum bars when they are attached to the 6-inch square mounting plates. After machining was complete, the ends of the bars were rounded on my belt sander and cleaned up on a floppy disc sander. This is a drawing of the aluminum bar with a roller bearing installed. I machined two plates here, a Delrin plate and an aluminum plate, and they're both 1/2 inch thick with the slots in them. I've already assembled the aluminum one, and I'm trying to compare these two, the Delrin versus the aluminum. Aluminum would be a lot stronger, but it's also a lot heavier. The Delrin is a lot lighter, and it may be actually quieter running on the lathe, so I'll be trying both of these out to see how they work. So let me assemble some of the roller bearings and the arms. A fairly simple assembly. It's just a roller bearing with a number 5 metric screw, a small washer on the bottom, and that screws into the bar. And that should turn smoothly. And then that goes into the plate like this, and that'll be sliding back and forth. Now I've been playing with 2 thumb screws. I kind of like these brass thumb screws, but they're smaller. But I have these plastic screws with a much larger head, so these will be easier to torque. So I'll be trying both of these also to see what I like the best. But that goes in there like that. And then you can adjust this and then lock it in place. I could also use these washers underneath the thumb screws to give me a little bit of a over friction plate, so that's another possibility. I didn't put it on these two, but I can. So that's my 2 plates assembled. And so these can be adjusted to whatever size bar I'm going to do, and you can center it. So now I'll take these both over to the lathe and we'll test them. I just mounted the Delrin plate assembly to the side of my Tormach 8L lathe. And I used 4 screws. And I drilled and tapped 4 1/4 inch 20 thread per inch screws. Now this side is only about 1/8 of an inch thick, so I did use longer screws. So I can always put nuts and washers on the inside if I want them to be a little bit stronger. But for just doing a prototype, I just using the threaded holes in the side panel. So there's 4 X-head, round head screws screwed into the plate to hold that in place. And this is my bar mount on here. This is a 26-inch long bar, and it's clamped in the chuck on the lathe. And I did use a centering piece on my end piece of the chuck assembly here. I think that helps a little bit. And I have this all mounted. I adjusted my bar, and I have the bottom bars tight, the top bar is tight. So we'll see if it moves at all as I'm turning this now. As I turn the bar, the wheels all move, so they're nice and tight. And I have my door locked open so I can run it with the door open. So let's start this at 1,000 RPM and see what it sounds like. Yeah, it's 1,000 RPM. There's almost no wobble out here. That's good. Let me take it up to 2,000 RPM. And these wheels are all spinning. And there's no lateral movement at all now, so that's putting these in the channels work quite nicely. So let's take it up to 2,500 RPM. That's 2,500 RPM. I can definitely turn with that speed now. Okay, let me take this off, and I'm going to put the aluminum one on next. Okay, I mounted the aluminum plate on here now with the roller bearings, and I have it all adjusted. And I think these bigger knobs on this one are a little bit easier to tighten. These are a little bit too small, I think. I do like the brass, but I think they're just a little too small. Yeah, I think I get a little more torque on the plastic larger knobs. So we'll see if it moves at all. So let me start off at 1,000, then we'll go to 2,000, then 2,500 RPM. So let's start at 1,000 RPM. That's about the same. That's 2,000 RPM. Let's go to 2,500 next. That's 2,500 RPM. So that worked quite nicely. Both of these blocks work good. However, I do prefer the Delrin plate. It's just a lighter plate. And when I look at the video, I'll see if there's any difference in noise, but I don't think there's any difference in noise level at all. I can always put a rubber grommet underneath these, between the screws and the plate if I wanted to reduce noise, but it seems to be fine, both of these. But I do prefer the Delrin plate. It's just a lighter block. And it works fine. And these larger screw nuts work better than these smaller brass knobs. I could also use like X-head screws to tighten it in place. So I could try that also. So let me put this plate back on, because I think I'm going to stay with this plate, but these work just as fine. I just reinstalled the Delrin assembly on the side of the Tormach 8L lathe. On the inside of the left side plate of the Tormach 8L lathe, I also added 4 washers and 1/4 inch nuts to each of the 1/4 inch by 1 inch long screws, used to attach a 6-inch square mounting plate to the side panel. Since this roller bearing assembly will now become a permanent part of the lathe, I just wanted to make sure that the screws would not come loose in the future. And I did remove this reducing collar from the end of the headstock tightening knob. What I found this did do, when I put this on, it did help center the bar on the outside. Now, these bars aren't perfectly straight, they're extruded aluminum. It was that a little bit, and this did help center it. So the other thing I did is I put a gauge on here to help get it straighter. Let me show you that, 1 second. So I used one of my gauges here to put it on the bar, and then I could rotate it. And I could adjust these to, kind of get it so it's, straight up and down. And that helped, because when I first put it in and took those out, in fact, let me show you that. You can see how much is out. It's almost a 1/4 inch. So I put that to the high point and use this to bring it down. Bring these in a little bit to hold it in place. And that's pretty good now. So I can tighten everything up. Make sure all my wheels are turning as the bar is rotating. That's pretty good. Let me start this right up at 2,500 RPM. Go to right to maximum speed. Now these are the 4 plates that show the history of development of this system for the stabilizing of the bar on the Tormach 8L lathe. This is my first prototype in which these roller bearings are actually screwed into this plate. And the disadvantage of this, they were not adjustable. They were a one-time fix, and it was set up for one size bar. It worked pretty well, but it was not adjustable, and it was hard getting it adjusted exactly the right thickness for the bar. Then my second prototype was this one with the sliding bars here, which work fine for adjusting, but what happened is with vibration of the bar, these would move like this. And so that didn't work nicely. We had to clamp these in position somehow to keep them straight so they wouldn't move laterally. So I then made my final two prototypes, one out of 1/2 inch thick Delrin and the second out of 1/2 inch thick aluminum. We then tested both of these units. The two assemblies have channels for the aluminum bars with the roller bearings to slide back and forth, so there's now no lateral movement of the aluminum bars. The advantage of the aluminum plate is that it's much stronger, but it's also much heavier. The Delrin plate is much lighter, but it may also be not quite as strong. It also might be quieter and actually might dampen the sound a little bit, but I did not notice any significant difference between the two systems during my testing. This concludes this video on these roller bearing assemblies for the Tormach 8L lathe, and I made two versions of the assembly, an aluminum plate version, which is 1/2 inch thick aluminum, and a 1/2 inch thick Delrin version. My personal preference was the Delrin version, just because it is lighter. I don't think there's any difference in operation, both work fine. I do like the larger knobs better than these smaller brass knobs, but you can also use small screws with hex heads to use an Allen driver to tighten them nice and tight, which might even be a better, tighter way of tightening these pieces. But they work fine. I eliminated the wobble in these bars without machining them, and I'm quite happy with the results. And I put this on permanently now, so it'll be a permanent part of my system for doing longer bars. This will enable you to not only cut and chew in larger bars, but also when making smaller pieces, I can put a longer bar in there so I have less waste of material as I'm machining, so I get more parts from a single bar. So I probably could go maybe 30 inches, probably about the maximum length I want to go on this. But I'll be using this quite a bit going forward, making parts for my systems. If anybody's interested in this, I will be making this available. I have all the parameters worked out on my lathe and my mill, so I can easily machine more of these if anybody interested. So if you're interested, just give me a call and I'll see what I can do for you. And once again, thank you for watching this video. If you have any questions or concerns or comments, as always, please give us a call or drop us an email. We're always happy to hear from you. And thank you for watching this video.